Now notice how example 4 changes. Okay, we're still looking at that same population of the 3-year-old, but notice how example 4 is different. Example 4 is asking us to find the height of a 3-year-old at the 20th percentile. Find the height of the 3-year-old at the 20th percentile. So just to refresh, percentile, that means that your score is better than the rest of the people behind you in the population, okay? So if I'm in the 20th percentile in height, that means I am taller than 20% of my population, okay? So there's people that I'm taller than in this aspect. If we're dealing with SAT scores, for example, if I score in the 75th percentile, that means I scored better than 75% of the people that are behind me. Okay, that's the key, that the rest of the people are behind you. So here on this bell curve, to be in the 20th percentile, this is going to be 50%. Okay, 20th percentile is right here. And because you're taller or you scored better than the people behind you, this is you right here, and this is everyone behind you. Okay, what that means is you're right there. Okay, and this question is asking us to find the height of the 3-year-old at the 20th percentile. Okay, 20th percentile, they gave us the area. The area is 0.20. So the go-to when it comes to the calculator is normal CDF, but I want you to make a note. We can only use normal CDF if lower bound and upper bound are known. Okay. We can only use normal CDF when the lower bound and upper bound are known. Do we know the lower bound in this case? Okay, so again, if we're looking at the shaded region, it doesn't stop going this way. We do know the lower bound is going to negative E99. But to use normal CDF, we need to know both bounds. Do we know the upper bound? Here, we do not, because we want to know what is the height right here. We don't know. So if a bound is missing, okay, if a bound is missing, we have a second calculator function that we use, opposite of the normal CDF. The setup is called inverse norm. Okay, inverse norm. So in the calculator, the way you find the inverse norm is by going to second farce number 3. Okay, the purpose of the inverse norm is to find missing bounds. So the 83 doesn't tell you what to put in. It just puts the function on the home screen, and that's it. I'll show you what the 84 screen looks like in a bit. It actually does tell you what you need, but you need 3 things. The inverse norm needs the following. It needs the area to the left, the mean, and the standard deviation. Those are the 3 things that this calculator function needs. Okay, so in our problem, do we have an area to the left? Well, we actually do. If we're in the 20th percentile, that means 20% of the people are behind me. That's area equals 0.20. So to find this missing bound, x is equal to inverse norm. Well, the area to the left is 0.20. So here we'll type in 0.20 in the calculator. Then we need the mean. The mean is going to be 38.72. Okay, that didn't change from the other previous examples. And then we need the spread, 3.17. Okay. What this will do is it'll find that missing bound at the 20th percentile, the missing bound. So if you notice, the mean was 38.72. That means on that number line, if we're finding the missing value, it should be somewhere below that 38.72. So when you hit enter, your missing bound was 36.05. Okay, so this is 36.05. So once again, we try and default to using normal CDF, but sometimes normal CDF, we don't have the pieces we need. If you're missing a bound, use inverse norm. Inverse norm will find those missing bounds from the number line. For the TI-84, I do want to show you what the inverse norm screen looks like for you. So let's go ahead and check and see what that looks like. Okay. So you still go to the same screen to get there. You need to do second vars, okay, and then for you, number 3 is the inverse norm. And for the inverse norm, it actually does tell you what it needs. It needs area, mu, and sigma. The 3 things: area, which is 0.20. We need the mean, so the mean of the 3-year-old height, 38.72. And then the spread was 3.17. For those of you using the TI-84, you'll paste and then hit enter, and it'll also find the missing bound, 36.05.